Welcome to HashTable 101. HashTable is a key value paired data structure that is also known as hashmap or dictionary. It is most commonly used for lookup operations as it provides a constant time complexity for retrieving, adding, and deleting elements. Typically in the array you have indexes pointing to your elements. These indexes can only be integers and don't really contain any useful information. Hashtables on the other hand allow you to use keys of any type from strings to your custom objects. These keys, just like indexes in your array, point to your elements. The hashing function converts your key into a hash code that is later turned into an array index that points to your value. This means that your key can now store meaningful information like an ID or a name of a person. Therefore, you do not have to iterate through your entire data structure to find someone with a specific ID or a name. This reduces your time complexity from big O of n to big O of 1. However, these hashing functions are not perfect. Sometimes two or more distinct keys can have the same hash code and point to the same index in the array. This event is called a collision. One of the most popular ways to resolve this problem is chaining. Each element of the array will store a linked list of nodes, and whenever a collision happens, the existing element will point to the next one as a node. This will create a linked list. Each node would have to maintain the original value as well as the key. So if I have an element that points to this linked list, then I would have to iterate through it. For each node I would compare my key and the node's key, and if the keys match, then I would return the value of the node.
Because of possible collisions and iterations, wouldn't that increase our time complexity to big O of n?
Well, not really. The hash functions are designed to be very powerful and effective, in a way that it almost certainly creates a unique hash code. However, even the most advanced hash functions cannot avoid collisions as the table fills up. Since there is less empty slots in the array, there's more chances of pointing to a non-empty index. For this reason, the initial capacity for hash tables is normally 1.5 times of the expected size. Even though this memory goes to waste, it helps to reduce the number of collisions. So, what are real-life applications of the hash table? Well, you can use hash tables to build graphs, where each key is going to be a node and a value is a list of connected nodes. You can also use this data structure to cache your application data, and most importantly, it is really helpful in coding interviews. If you ever struggle with an interview question, just throw a hash table at the problem. Thanks for watching. If you enjoyed this video, please like and subscribe, as it would really help my channel grow.